Hi guys, a warm welcome to this series which is on machine learning fundamentals. We are discussing today episode 6 which will be related to unsupervised learning. First of all, before we can just take certain examples in Python related to unsupervised learning, unsupervised models, it is very important that we understand first of all what are the characteristics of the problems in hand that can be solved with unsupervised learning. When we are talking about problems, we mean to say problems with the data, the kind of data that we are having, and then we can work on that data, and then we can get the desired output from there. I would like to take some examples before I can just go and do things practically, taking some of the basic examples in unsupervised learning and implementing them in Python. That will be something which I would like maybe a part B of this episode 6 to take in. But this might be, you can just say part A of this episode 6, where I would like to first of all clarify that what is first of all unsupervised learning. One more time to explain it. That is something very important, and then after that I'll be showcasing you the data as well. So let me just go to this, show you the screen, which will be showing, in fact, displaying. Just one moment, I'm having some issue in the display, but it should be fine. I will just try to capture this. Yeah, it should be perfect. So yeah. So unsupervised learning, the definition, we have in fact gone through this already. uh, Unsupervised learning is we are learning patterns from data without labels. No predefined answers are given there. So definitely it learns patterns from data without labels. There are no predefined answers that are given. And what unsupervised learning can do, first of all, we need to see the characteristics of the data, what kind of data it is, and which are not having definite labels there. So it can group similar data, it can find hidden patterns, it can discover structures. So this is what unsupervised learning can do. There are a lot of implementations, in fact implementation areas, application areas, in which it can just do in fact wonders with the kind of data. So for example, some of the examples that have been given, customer segmentation is one area in which we'll be exploring some of the basic examples first of all, and then we can go to advanced examples as well. Recommendation systems, definitely. This is one more area where we can just use unsupervised learning. Fraud detection is one of the areas as well, where in fact multiple features are there, but they are not leading to a specific labeled class, where in fact we can use supervised or supervised learning. So unsupervised learning will be in fact very suitable for that. Image grouping is one more area where grouping of images will be happening. There will be multiple, but it is not giving us actually, it might be giving characteristics of an image, different features, but it is not giving certainly that this particular image will be fit here. And data compression is one more area in which we can just utilize. So these are applications, but the applications of unsupervised learning, realistically they are not limited. There are many applications which we can have for unsupervised learning. And in fact, this one thing I first of all wanted to show you. Let me just take you to one more thing, where I would like to just show you this data. So if you just see this data, it's an unsupervised learning sample data. We are having customer, actually this is customer clustering, where grouping of our customers can happen. So if you just see this data, it is having customer ID, age, annual income. It's having spending score, online purchases per month, and then store visits per month. So you can just see this is a data of different customers with customer ID. But none of these features which are given here, they are leading to something which is uh, which will be having some column which will be giving us some categorization of the customer. So none of these fields. So what we need is actually there are no label columns present. So there is no label. There's no label column present. That is also shown what kind of things are not there in this particular data. Customers can be grouped by similar characteristics, similarities which are there. So we can just say they can be grouped by annual income, their spending score, online purchases done, or store visits. So you can just group them in multiple ways. So that grouping, it depends upon what kind of grouping. Usually useful for K-means or hierarchical clustering. So this particular set of data is suitable for unsupervised learning like K-means, uh, PCA, principal component analysis. So we are going to go into these. In fact, do these two first as far as the unsupervised learning is concerned. There are typically hidden groups in this. For example, you can have high income, high spending. You can have medium income, medium spending, low income, low spending, or there can be a case where there is a high income, low spending, and a low income, high spending. So that also can be there. But these can be explored, and this can happen with unsupervised learning. So what we have understood, what we have learned is unsupervised learning. First of all, it is used on unlabeled data. We had discussed it earlier as well. What unlabeled data means? Unlabeled data means the feature set of the data does not lead to something specific. So when we are training a model, we cannot give some specific output to a particular input based on that, on which a model will learn. Like we are doing it in supervised learning. We have taken numerous examples there. For example, the study hours of a student leading to the percentage of marks, or classification whether a student is going to fail or pass. That was a labeled data which we used to input to a model to train it, and it was learning from there. And then on the future data, we were predicting results of students. So that is something which is there, a supervised learning problem, where data is having a specific, the data you are inputting, it's having labeled column, labeled feature, which can be taken as a conclusion, and on the basis of which model will be learning. But this data which is now in front of you, it is visible. This data is not leading to a column, no labeled column is there present. So for this one, it is suitable to have unsupervised learning. So let us just go now and take some few of the examples there, and then in fact with those examples we'll understand it better. So uh, let me just go to and take unsupervised learning. So this is the thing which is there. So it is displayed on your screen now. It will be there on your screen. So if you just see unsupervised learning in Python, so we'll be deploying it using Python. So there will be complete executable codes, in fact, available for both K-means. We'll be taking separate problems for both of them. So unsupervised learning does not use a target label. So there is no target label. You have seen that from the data I had shown earlier. The algorithm receives raw features, values, and discovers. So what the algorithm is receiving are raw features. So those features, the columns you have seen, for example, features of customer. So customer ID, then it is online purchases done, those purchases which a customer has done while coming to physically purchase, and then some other characteristics which are there, spending, trend, or some other things. So it is having raw features, and discover structures such as, so we can discover, in fact, by using unsupervised learning, we can discover structures such as groups, compact representations, or unusual points. So all of these things can be discovered. Um, we are having, in fact, two examples. One is with the PCA, yeah, principal component analysis. In fact, we'll be just doing the implementation maybe in part B of this particular episode 6, and K-means clustering. We have to understand both of them. In fact, I'll be having a comparison to these two. I think that will be something which will be very feasible to first discuss, and then we'll be going ahead with the main slide, and then onto these uh, implementations or implementation in by using Python. So if you just see this particular slide, which is now displayed, we can just see from here a very brief comparison that has been given between K-means and PCA. K-means is a clustering algorithm. So what it does is it groups similar data. So it will be grouping the similar data. Then what is the output of this? It will be putting a cluster labels. So output of this particular algorithm is it will be putting cluster labels. So it will put a label, a categorized label, that will be output of this. So it will be categorizing and putting a label on that, giving us a label data. So customer segmentation will be one example. For example, we are giving certain characteristics, features of a customer. For example, we are inputting customer ID, we are inputting spending per month or spending per year, income per month, like these columns. And then it can give us what group of what group this particular customer belongs. We can have multiple groups. For example, we are having low spending group, medium spending group, high spending or elite spending group. So we can have multiple groupings depending on what we want to achieve. So this is K-means. Now, what about PCA, principal component analysis? It is a dimensionality reduction. It is not clustering, but it will be reducing the dimensions. For example, the features. There might be numerous features in a particular data. First of all, it will be reducing them. So reduces features. So it will be reducing the features. And then what will be the output? It will be new components. So definitely the feature set that has been given. So it will be first of all reducing, and then we'll be having feature reduction. So what can happen? I can just give a scenario, a complex scenario where, for example, on a set of a data, first of all we can apply PCA, principal component analysis, so that we are able to. We might be having very complicated data. On that we can first of all apply PCA, principal component analysis, so that we are able to reduce these number of features, and then we can just have K-means, so that we'll be able to get the categorization, segmentation, grouping. So what we intend to get, and it will be a clusters labels. So it will be a label data which we'll be getting in hand, and this is what can be done, and we will be getting as an output from there. So first we can apply. So this is normally what happens, that we are having a very complicated data on which we are applying PCA, and then we can have K-means. And with this one, I think it would have been very clear that what exactly we are looking at, and in fact we are in a position now so that we can just go through the main slide which is there, main content which is there for this. If you can just see this one, I'm just putting it on screen now. You will be having supervised what supervised unsupervised learning solves. So first of all we'll understand this, and definitely then we'll be having an example, probably that might be there in episode 6b. So first of all, understanding it is very important, and then we'll be implementing it in. So what's unsupervised learning solves? The input has features only. There is no target column, so we don't have any target columns. Feature set only. So clustering, we can have multiple things. We can have dimensionality reduction, which we have discussed, and we can have clustering. So clustering is achieved by the k-means, and dimensionality reduction is achieved by the PCA. So clustering goals groups similar rows together. The data already contains, definitely natural segments. Typical output, in fact, is cluster ID for each row. So we're having a cluster ID, a cluster centroid for each group, a visual split of the data into segments. These kind of things, which are given there, are typical outputs, goals. Actually, typical output you will be able to understand when we are working on an example. So what example we can work on this, for example, for k-means is customer segmentation from income and spending scores. So we're having spending scores and income, and from there we should be able to get the segmentation, grouping of customers. Dimensionality reduction, when it comes, goal is compress many features into, as I was defining already. I have compared the two as well. So what is the typical output of this is a lower dimensional feature matrix, which will be having more, and we are reducing it. uh, Explained variance per component, a cleaner 2D or 3D visualization, and examples in this particular deck are PCA projection of gadget feature profiles. We can take different examples. In fact, I am having a similar example as well for this, which I have planned for this episode 6B. Why these both matter? K-means answers which observations belong together, and PC answers how can a high dimensional data set be summarized. In fact, compactity, in a compact manner, how that can be it will not be compromising with what the data is speaking, or we can just say the credibility of the data, or what data tells us, the information of the data. No, it will not be compromising on that, but at the same time it will reduce, it will compact it, it will summarize, it will compact. So together they cover two most common entry points into unsupervised learning. No label common is used in either examples. So no label column is there in both the examples, that is true. And We are going to see these examples, first of all the basics, and then we can have maybe one program or one example where both of them can be implemented, applied, and will be in fact generating and achieving a desired outcome. For now, I think, this first, I don't want to keep videos uh, in this particular series too long, so that it will be a little difficult or boring for the viewers to go through and comprehend those concepts. I want to keep them short and sweet, and to the point. So this is the explanation of unsupervised learning, which we have gone through. In next one, which will be episode 6B, we'll be covering the practical implementation with basic examples in both k-means and PCA, and then we can combine them to a single example and implement that as well. I hope this particular video would have been very useful for you to understand unsupervised in a much better, clearer way. And you leave your comments. You can subscribe to the channel to get the updates on this whenever a new video is uploaded. See you then in next episode of the unsupervised learning, which will be talking about practical implementation of these. And thank you so much for connecting.